Right. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. So we continue with our next subtopic, which is process and process variables. So I'm hoping that you can follow my previous lecture, and based on my feedback on that, based on my feedback form that I gave on Monday, most of you can follow whatever I'm taught you in the lecture video, but maybe some difficulties on you to understand in dimensionless. Uh, However, based on the assignment that I gave to you, mostly all of you can get the right answer. So give me some time in order for me to mark that assignment, and then I'm going to distribute back lah to you. Okay. All right. So we are going to proceed with process and process variables. So what is process and what is process variables? Okay. Okay. Sorry, give me a second. Okay. Uh, process is any operation that cause physical or chemical changes in substance in a mixture or a of substance. So basically, imagine that you have a process, you have a microwave. Okay, you want to bake a cake. Okay, so what is the process? Okay, the process name is baking lah, because you want to bake a cake. Okay, so what a process unit or unit operation? When process unit is an apparatus that you use for the process to be occur. Okay, just now I gave to you the example about you want to bake a cake. So what are unit, what are tools that you are using for to bake a cake? So you are using a oven. Okay, so that oven is the apparatus that you use in order for you to carry out the baking process. Okay, so what is the input? Okay, input is any materials that enter the unit process. Okay, so let's say we're talking about the oven just now. So what are the materials that we put into our oven? So uh, we put flour. There is flour. This mixture of flour, some water, some eggs, and also some other smaller portion of ingredients, such as maybe you have some sugar, or maybe you have some colorings. So that are the input. Okay, so what are the output? Okay, output is anything that leave your unit operation. So your unit operation, we're talking just now, the simplest example that we're talking just now is that we talk about oven, right? So after you put your mixture of all your ingredients, so you left your uh, mixture in the oven, and you turn on the switch, you set the temperature, the time, and then at the end, what the uh, what are the materials that you can take out from the oven is the cake itself, a cake. So the cake is what we call as output or a product. Okay, so let's say we have a mixture here. Okay, these are our mixture. So there is you want to mix between salt and water in this example lah. So these are your input, salt and water. Okay, after that, after those input go into your mixer, and then it mix together. Okay, and then at the same point of time, and then it's going to go out from your mixer, which is your unit operation, as a salt water. Okay, so salt water we call as output. Alright, I hope you understand. Okay. So what are the process here? The process we just call a simple mixing. Alright. So in every process we have a process variables. What are the process variables? There is a lot of process variables. Okay. So basically we can divide into 5, which is mass and volume, flow rate, chemical composition, temperature, and pressure. So this thing is some different units that we are going to use. Okay, so we are going to go into detail one by one. Okay, so the first part we are going to touch is on mass and volume. Okay, in mass and volume, basically we are going to learn about density, specific volume, and specific gravity. So I believe that you have been using density a lot of time in your previous matriculation or STPM. So what is density? Density is mass per volume. Okay, so that have a few option of units. So maybe you have kilogram per meter cube, gram per centimeter cube, or pound mass per feet. Okay, yeah, the density is been used to relate between mass and volume. Okay, so next we have specific volume. What is specific volume actually? So specific volume is inverse of your density. Okay, if density we have mass per volume, then specific volume we have volume over mass. It's just vice versa of your density. Okay, so what we have, the unit will be meter cube per kilogram, centimeter cube per gram, or feet cube per pound mass. Okay, next we have specific gravity. Okay, what is specific gravity? Is a ratio of the density of a substance, any substance, but over density of reference of that substance, but at certain condition. Okay, what the certain condition is? The reference is water at 4 degrees C. Okay, that is the density of reference. So let's say, so these are the formula that correlate between your density and over density of reference at certain condition. Okay, so hopefully you can familiar with this formula, because sometimes in questions, in final question or in test question, they are giving you this specific gravity, and you need to find the density of that substance. Okay, but basically the conversion here, it will be given lah. Okay, in appendix of the question. Okay, just remember the correlation between specific gravity and also the density. Sorry. Okay, see. So these are the short form. The mind map that easy for you to understand. So the correlation mass and volume. Okay, we can use density, where density equal to mass over volume. Okay, and then the specific volume is inverse of density. Okay, so let's say if density is mass per volume, then specific volume is volume over mass, or we can call it, or we can short form it 1 over density. Okay, so density, we can use another equation to find density by using specific gravity, by using this equation. Okay, the specific gravity equal to the substance density over the reference density. The reference density is based on this one lah. Okay, at 4 degrees C H2O. Okay, so these are the correlation. Please, I'm not sure if all of you have a background of taking any chemistry in previous school or previous matriculation. If any of you that haven't take any chemistry subject in their life before this, please let me know, because it's quite difficult for you to catch up what this subject is going to learn. So please let me know personally that you haven't take any chemistry in your whole life. Okay, so that I can give you maybe more example, something like that. Okay, we go to short example. Calculate the density of mercury in pound mass. Okay, this is, we call it F pound. This is M equal to mass over feet cube. Okay, you want density of mercury in certain unit, which is pound mass and over feet cube, where the that information that the question gives is specific gravity, okay, of mercury is 13.546, and you need to second question, you need to also calculate the volume in feet occupied by 1 to 5 kilogram of mercury. So how you are going to do this? One by one. Find the density of mercury in pound mass over feet cube first. Okay. So the specific gravity of the mercury is 13.546, and we know that the equation that correlate between specific gravity and the density is like this. Okay. Alright, so what else they give? So we know that from the previous what we call previous slide, the density of reference is at pound feet is 62.43 pound mass per feet cube. So we are going to use that one. So this one is 62.43. This one is 13.546 as given in the question. So what is the density of mercury then? So you can multiply lah. So 13.546 times raw reference is 62.43 pound mass per feet cube. So what is the final answer for this question? You will be getting 845.67 pound mass per feet cube. Okay, so you settled for the first part of the question. You go to the second part, which is you need to calculate the volume in feet cube occupied by 215 kilogram of mercury. Okay, since this answer you get in pound mass, what you need to do is you need to convert in kilogram, since the data that they gave is in kilogram. So this is why I put the conversion factor here, so it's easy for you to refer to. Alright, so 84567 pound mass per feet cube, you want to change to kilogram first. Okay, so where is that? Comes with 1 kilogram equal to 2.20462 pound mass. So this one should be 2.20462 pound mass, and this one should be 1 kilogram. So you cancel out this one, you cancel out this one, at the end you'll be getting kilogram per feet. And then what you need to have, you want the volume. Alright, so we know that rho equal to mass per volume. So we have the density, right? Are we? Yes, these are the as density actually, right? Okay, so density will be after we get this answer, put here kg per feet cube, mass will be 1215 kilogram per v, per the volume lah. So you calculate and then you take this one on the left hand side, then 215 divided by those value, you'll be getting 0.560 feet cube. Okay, you can understand and follow. Alright, next we go to the flow rate, the next subtopic, which is flow rate. Okay, flow rate can be given in two types, which is mass flow rate and also volumetric flow rate. Since it's a rate, so it must be over time lah, either second, minute or hour. Okay, and mass flow rate is either kg, gram, pound mass. Okay, so basically either the symbol is m italic, or we can just put the dot on top of the m. And then the second one, we can also have a volumetric flow rate, as in name it is volume, so volume over time lah. Okay, the symbol is italic v, or you can also write it as v dot on top. Okay, we know that the density is mass over volume, right? Okay, so this actually, the volume, the mass flow rate and volumetric flow rate also can be related back into the with the density. Okay, we can see from here. Okay, this one is mass and this one is volume. So this one is mass flow rate, and this one is volume flow rate. So you can actually use the density, use the volumetric flow rate and also mass flow rate with the density. The correlation is just the same because you can cancel out the time. Okay. We go to the simple example. Okay. Alright, water is flowing through a pipe with a volumetric flow rate at 24 gallon per minute. Determine the mass flow rate. Okay, mass flow rate in pound mass per minute. Assume the density of water is 1000 kilogram per meter cube. Okay, so this one is volume flow rate, and this one they want to change to mass flow rate. So but it's given the density. As I mentioned just now, you can correlate you can correlate your mass flow rate and volume flow rate with the density. So using the same equation, density equal to mass flow rate over volume flow rate. So okay, the density will be 1000 kilogram per meter cube equal to mass times V, right? Okay, now you cannot simply just multiple because the unit is different. So this one is gallon and this one is meter cube. So what you need to do? You need to convert first. Alright? So up to you, either you want to change to meter cube all the unit to meter cube, or all you want to change to gallon. So what I'm going to do is I'm going to change to meter cube. So we know that for volume, mana gallon? Where's gallon? 1 meter cube equal to 264.17 gallon. So this one should be 264.17 gallon. This one is 1 meter cube. So you can cancel out later. Okay, after you done the calculation, you can get kg per meter cube equal to mass flow rate divided by, okay, you want to solve this problem first, and then this one you get 0.09085 meter cube per minute. Alright, so in order for you to get the mass flow rate, 1000 kilogram per meter cube times with 0.09085 meter cube per minute. So what you get here? 1, 2, 3. 9085 kilogram per minute. But since it wants the mass flow rate in pound mass, then you need to change your kilogram to pound. Okay, so you can try, you continue lah. 9085 kilogram per minute, then we know that 1 kilogram equal to 2.20462 pound mass. So you do the unit conversion. So basically for the few weeks at the beginning, we just learn how to convert all those units. Okay, it may seem easy but a bit confusing. Okay, so you do your own calculation, you will get 200.3 pound mass per minute. Okay, that's it. Next, we go to the chemical composition. This one is also basic of chemistry. I think most of you know already. I just recall back. So what is atomic weight? Is a mass of atom on a scale that assign carbon that have exactly 12. So it's comparing between the your substance with the carbon lah. Alright, and then molecular weight. What is molecular weight? Is a mass per mole. Okay, this is the equation where the sum of atomic weight of atoms of a constitute molecule. So let's say you have H2O. So you have 2 hydrogen plus 1 oxygen. So we know the weight of the hydrogen is 1 and oxygen is 60. So the molecular weight is 1 plus 1 for hydrogen, 16 for oxygen. So you're getting 18 as a molecular weight of water, H2O. Okay. Next, we recall back what is mole and mole in unit SI or gram mole or G mole lah. Okay, it's the same thing actually. Alright, is amount whose mass is equal to its molecular weight. Alright, is a basically is a mass lah. Okay, unit can be mole, gram mole, mass, pound mass per mole, and kilomole. So basically, it's the same. How they write it is different. Okay, its molecular of substance in X, there were is X kg per kilomole. Okay, so these are the example. The equation. So let's say this is gram. So you are using mass in gram. If talking about pound mole, so you are talking the mass in pound lah. Okay. Next. Simple example again. So you have a bucket holds 2 pound mass of sodium hydroxide, which is the molecular weight of sodium hydroxide is 44. And how many pound moles of sodium hydroxide gas is contained? Okay, how we are going to calculate it? So they're talking about moles. So we know that molecular weight is equal to mass over mole. And the molecular weight of the sodium hydroxide is 44. The mass is 2.0 pound mass divided by mole. Where I get this equation? This one, sorry. From previous slide, this one, molecular weight, and equal to mass per mole. Okay, get back to this equation question. So how many mole you have? 2.0 pound mass divided by 44, and you will get around 0.045 pound mole. Okay, and for B, how many gram moles of sodium hydroxide does it contain? So they are talking about grams. They want the answer in gram lah. For the first one, they want the answer in pound mole. So the next one is gram. So basically, you using this one and convert back to gram. So back to the unit of conversion, 0.045 pound mass mole. You want to change to gram. So the bottom will be pound mass and up will be in gram. So look back. 1 pound mass equal to 453,593 gram. Okay, so when you you multiples, you will get the answer around 20.62 gram moles of NaOH. All right. Okay, let me check. Either I'm using the 0.45 times 4.5. Okay, more or less okay. Either 20.4 to 20.6, between that answer. Okay. Next, we are talking about chemical composition. All right. Chemical composition can be there is two ways in order for us to read it, either mass fraction and mole fraction. Okay. If mass fraction, that you're using mass lah, the unit will be gram, kilogram, or pound mass. And let's say you have mass fraction. Let's say you in the tank you have a few substance such as A plus B plus C. Okay. Sorry. Right. Okay, let's say you have in tank, you have A plus B plus C. So let's say if A you have 50%, you have 50 gram, B you have 20 gram, and C you have 30 gram. Okay, how you're going to calculate the mass fraction of A? So the mass of A is 50 gram, and total mass is 50 gram plus 20 plus 30. So total up you have 100 gram. So what is the mass fraction of A? 0.5. That is mass fraction of A. Okay. So let's say how you're going to calculate the mole fraction of A. So let's say I have 50 gram mole of A, 20 gram mole of B, and 30 gram mole of C. So it's the same things. Moles of A you have 50 divided by 100. So 50 by 100 divided by 100 is 0.5. Okay, this is different sample. Okay, I just take a value, randomly value. So doesn't mean that A and the example that I gave two question just now is the same. Okay, it's different situation. Okay, because I don't want you to mix up A 50 gram of A equal to 50 gram mole of A. No. It's not right. Okay, I just give you two different example just for easy to calculate here. Okay. Next, average molecular weight. So these are the equation lah based on mass fraction. These are the equation. Okay, X means mass fraction lah, mass fraction. Okay, kalau based on mole fraction, then you use Y. So these are the equation. This is mole fraction. Okay. Okay. Still in chemical composition, but in this thing, you have three types of three different things you need to learn, which is mass concentration, molar concentration, and also the concentration in terms of how you multiply lah. Okay, mass concentration, as it names, mass. Alright, so it must be mass per of component per unit volume. So we use this one, the unit. And we also have molar concentration or molarity. As it name molar, so you using moles. Okay, same thing, you have to divide by the volume. Okay, how you are going to convert mass to the molar? You are using, you times with the molecular weight of the substance. Alright, next is concentration, whereby you where there's a certain substance, you have a lot of numbers, then you can use this as a short formula, parts per million or parts per billion. What is part per million? So this 10 times to the 6 and billion times 10 times to the 9. Okay. Alright. Okay, concentration factor can be used to relate mass flow rate of a component of a continuous stream to the total volumetric flow rate. Okay, concentration factor. Alright, so given this example, given 6 liters of 0.02 molar solution, so this molar solution of now contains, so this 6 liters is the volume. Alright, this one is your molar lah. So they're asking how much the mole of the NaOH. So we know that they give the volume and also they give the molarity. Okay, this is their molarity. So then you multiples, then you get the moles lah. Okay, this is molarity. Okay, next. Okay, wait ah. Okay. Alright, 0.5 molar aqueous solution of H2SO flows in a process unit rate of 1.25 liter cube per minute. The specific gravity of solution is 1.03. Calculate the mass concentration and the mass flow rate of H2SO4 and the mass fraction of H2SO4. Okay, this one I'm going to give you another video to solve this. Okay, I'm going to finish up the lecture first. Okay, so next we are going to learn about pressure. Okay, pressure is the ratio of the force to the area, F over A. So the unit can be Newton per meter cube, meter square, Joules per centimeter square, something like that lah. Okay. So this is the equation. If you want to you want to calculate the pressure here. Okay, so rho naught is on top and this one is liquid lah, because you imagine that you have a container or a tank that have a liquid inside and you want to calculate the pressure that exerted on bottom of the tank. So these are the equation that you use. Alright, and then the relationship between the base and the top can be given as a head. Okay, okay. So it's the same thing as it just he give you another type of equation. Pressure P or not in millimeter mercury plus H. H is height, okay, height of the tank. Alright, this one is P absolute equal to P gauge plus P atmospheric. So if you want to calculate the P absolute here, so you need to know the P gauge, where you put a pressure gauge here, pressure gauge where you can read the pressure, okay, indicator here. P atmospheric basically 1 atm lah. Okay, so this is another equation that you need to familiar with. Alright, what is P gauge, what is P atmospheric? Okay, next is temperature. So temperature can be, there are a few units, either Kelvin, Celsius, Fahrenheit, and Rankine, and these are the equation that related between those conversion. Basically, you can change your temperature unit to one to another by using your calculator, but then I'm not sure if you know or not, but with my scientific calculator 570, it can be done. Okay, so this one just show you the difference lah. Alright, okay. Okay, I think this one you can try by your own, because I have done, I have explained in previous slide. You can try simple with just weight fraction and mole fraction. The x a and x y just now I explained. Okay. Oh sorry, this one. Uh, I will give you the link in separate link later. Don't use this, okay? It's just another quiz, short quiz, simple, just like previous. Alright, that's all from me. I will give you another sheet for your short assignment as usual. Okay, that's all from me. Thank you everyone. Assalamualaikum, bye.